sorry. Yeah, so class 1, let me create a class 2, CLS enter maybe 1. Let me take this 1 maybe. Let me create one more class here, class CLS enter. Yeah, so you have 2 classes here. Now let us say this is my first thread, which is let us use some implements, or you can also use some in extends thread. Yeah, now here, so what we want to do is we want to use some communication in between these two threads using some internal classes, internal stream classes, which is pipe classes, right? Let us see how to do that. So let me just say catching here, and for reading and writing, so our agenda will be, so this thread 1 will be feeding data, right? So it will be continuously feeding data, and that feeding data will actually get to the second thread, and we'll have to print whatever it gives us, right? So we'll handle that in thread 2, right, using pipes. So here, so we have 2 components under pipes, which is pipe reader and writer. You can use pipe reader, which is that means the LOBJPR, pipe reader is equal to new pipe reader. So you can see pipe reader is under IO. So we'll be learning what are the different things which comes under IO, which are files and different streams, right? And you have pipe writer LOBJ, let us say WR is equal to new pipe writer. So we are actually creating a separate pipe for writing something. So we'll be passing this on to first, and then we'll actually get the data from reader, and we'll be using that from thread 2. Now what we have to do is we have to actually connect these 2 pipes. So how to connect this? We will be connecting this with writer dot, you have something called connect, you can see reader, right? I'll connect with this. So now these, you have just used a connection in between these 2 pipes. Now whatever you just push into pipe writer will be pushed to pipe reader, and in turn it will read from your next thread, right? So now let's go back to our first thread now. So now you understood like how we are going to do that. By now itself, I hope you understood how we are going to do that, right? So first, to the first thread, we'll be taking the pipe writer and we'll be writing something. So automatically what it does is, automatically when it comes to pipe reader, it will automatically read something, right? Yeah, let's go back here and let us write some constructor, because we have to handle pipe writer here, right? So take the pipe writer over here, right? Let me just say LOBJ same PW is equal to new pipe writer. Oops, sorry. Let me just take it as null first. I don't want to instantiate anything here, so that when I come to enter P1, I'm creating my constructor here, and I want to accept my pipe writer over here. Okay. Pipe writer, let me just call it as a W, and LOBJ pipe writer is equal to my W. So I'm just pushing my writer into this. In the same way, what I'll do, I'll create a thread over here, thread 1. So this part is creating a pipes, and this part will create threads now. Thread, let me call it as T1 again, is equal to new CLS enter P1 of pipe writer. So it wants pipe writer, so I'll give the pipe writer object to this, right? So now let's go back to our first thread 1, and here we have to do something to actually feed something to the writer. Now let's see how can we feed our data to writer. So what to feed now? So let us take infinite loop. Let me just call while, or you can just take for loop where you don't have any signature. Right. Just say this, and let me just take a int I is equal to some 0 in here, and continuously what we'll do, we'll create a string pattern, string lstr pattern maybe is equal to, let us say, created at parent level, just level, let me just print I, right? Let me just print I, and I can use I++. I hope you understand this, right? So what it does, it will first assign I and then it will increment. So I can use I++ anywhere here. Right? So what I'll do, I'll have to push this to my writer. Now if I want to push this, right, you have to do something called write your string. I'll just use this, right? So I'm just writing into this pipe writer. So I'm just pushing my data pattern something to this, right? Yeah. Now what I'll do, I'll have to flush out first stream every time. So what is a flush and all, you learn in file systems, right? Because every time if you are writing something on stream, right, you should always do something called flushing, because without doing a flush, what happens is there will be some part of characters or bytes will be remaining. So next time when you write something again, what happens is those bytes or characters will be added up to the new request and your request will be corrupted. So that's why what you are doing is, when you write something, let us say you have poured some water, right, or something, right, and then what you are doing is you are just cleaning up your pipe, and then you are pouring a next request, cleaning up your pipe, pouring a next request. So in that way you do, right? Fine. So now what we are doing is we are just placing the data. No, inside this let us just handle some try catch here. So I'm writing something which is an infinite loop just to see it work, and later we'll just see how to actually kill this from one pattern to another, right? We'll see that. Right? So using this we have just, let us say continue here. So whatever exception happens in between, right, I don't want to kill this, I just want to continue everything with that. Now let's get back here. Now we are done with the writer one. So where we have seen something, right, we are just writing something into pipe. Now how to create a reader for this? So let's come here in thread 2. Let me create a piped reader, right? I think it's called as lobjpr, pipe reader is equal to null first, and then I'll create my constructor here which accepts public, which accepts pipe reader. Let me just call it as R and just say lobjpr is equal to R. So we're just taking a constructor. So whenever anyone wants to build this object of this thread class, right, they should have a separate constructor which accepts only pipe reader. Now let me just extend this with a thread so that I can use it as a separate thread class, and then here create a run class. Now we'll see how to read that. So reading again is the same fashion we'll be reading, like so. Again let's take a infinite for loop again. This time let us take a infinite while loop, while of true, something just to make a difference, while of true. So what we'll be doing is, first we'll be handling our try catch. So if any exception happens, I want to continue my loop. So I want to continue my loop, and what I'll do here, now we'll be using this pipe reader. So how to use this pipe reader? So let me just catch up that in my string again, string lstr maybe I can call it as a read is equal to, you have pipe reader, which is lobjbr, right, dot, you have something called read here. So read will give you the complete characters into your now. So this will give you an object, so we have to convert it into something called string. Let me convert it to string. This will give you something called reader here, so it is giving you interesting. Let me just take the char here, not an issue. CHR E, let's convert it to char here. Yeah, so it got converted into char here. Now what we'll check, so every time it may or may not get something which is exact value, right? So let us just do, if we have something called lchr read, right? So this char, sometimes it may not be so this read, every time it will give, if there is no data in it, right, it will give something called -1 to you. Let us just check with that. If it is not equal to -1, right, then this, right, if your char is not -1, right, just say sys out of lchr read, right. You just actually reading up everything we want over here, right? And let us just here. So here, so what we have done is we have just connected back everything in here, yeah. And hello, can you guys hear me? Okay, so finally we'll just do something in here, because this finally will not be reached, because this is continuous block here, which is try catch, and we'll keep this finally over here. So once we are done, we'll just say sys out of that. Guys, you can mute up your side. We're getting some disturbance from I think one of you. You can just mute your mics, right, everyone. Yeah, thank you. Yeah, okay, so out of that, let us set 2, right? So now what we have taken is, we have taken
Srinath, sorry, I have a quick question.
Yeah, Ron.
The L character read not equal to -1. Why -1? Because of a false value, or?
Yeah, so -1 is nothing but actually it's an end of, so normally whenever we are reading a stream, right, whenever it comes to end, it will give you a, it starts giving -1 value. It says it represents that it is the end of the stream or end of a file, right?
Okay.
Yeah, so that's why we read -1. Like if you don't push in anything, if it is not getting anything, right, it will get -1 actually, right? So there are different streams. So if you take up a buffer reader stream, so it will give you null. Sometimes when you use buffer reader stream, then you have to check something called null. So it is different for different streams. So we'll understand that when we come to files, right? So that's why I'm not.
Srinath?
Yeah.
Yeah, minus. It's an like empty string, right?
It's an.
So we are checking that the string is empty or not. And
Exactly.
then
It can be. Yeah. It also can be an empty string. So it is an empty string, and if there is nothing here, it will be. So actually, this is not actually care. For a printing I'm taking in. So let me just take this. You can take int lint read. Okay, so where I don't want anything, because this read actually, if you see this read, right, it will give you my int. So the basic thing you can see here, right, reads the next character of the data in a pipe stream. If no character is available because of end of stream has been reached, the value -1 will be written, right? So this data will be, I'm reading continuously something, and what I'm doing is I'm just printing it. So this reader will read character by character, right? So that's how it is actually reading up. So whenever it comes to -1, right, it means the whole stream is been ended. So again it will try to read something else again, right? So that is what is the meaning of this. Fine. Yeah. Okay, fine. So here that's what is, I'm reading my integer here, and what I'm just printing it out, right? So for this integer, what I'm doing is I'm converting it to char actually. LCHR, maybe I'll just say some data is equal to, I'll just convert this into my character, which is character. I'm just typecasting this one and to my character, and I'll print this character data into here. Right? I'll just print of this character. So we have to create a string out of this, right? So just printing it out in an infinite loop. Right? Anyways, don't get into much of streams, because before this we have to understand what is a stream and how it works, right? So we'll understand this part when we actually come to file systems, right? Yeah. Let's go. What is the problem here? CHR read. Okay, sorry. Yeah, see, that is what it says. Cannot be resolved. Yeah, let me just clean up this, so that, yeah, it will gone. Yeah. Now, so let's go back to our next thread, which is, I want to create a thread T2. Thread T2 is equal to new CLS enter PT2, where I want, sorry, enter P2, right, where I want my reader, right? So two threads in a reader, right? So this reader will come to this part and will assign the reader here. So this reader will be chunked up here. Now before doing anything, just check whether your reader is not null. Your LOBJ reader is not equal to null, then only it should work. Because sometimes if your constructor is not instantiating your reader, it will throw you an error. So that's why it's always better to check this, whether it is a null or not. In the same way here, check if your LOBJ writer is not equal to null, then move ahead and do something else here. Every time you move in this way. So every time this should be something which is the same writer, because I'm not instantiating my writer, because I'm getting the instance of my writer from here. Nowhere you will instantiate any of the reader and writer, because if you re-instantiate this reader or writer, right, your connection again will not work, because we are connecting to pipes which is reader and writer of these instances. So in any of the one thread class, if you create a new instance of either a reader or a writer, which means this connection is different. This connection is taken from these two instances, right? So that's how it comes. Now let's start your T1 and start your T2. Okay. So we have started 2. So when we start T1, it will come up and let us see. I have a complete string pattern where we are writing some thing in here. Okay, we are actually pushing it to my this reader, and yeah, it's a flushing up every time we do flush up. Yeah, cool. Then when it comes to, even if, okay, so here what we'll do, instead of writing a flush here, what we'll try to do is we'll try to do it in finally, because even if your write fails, you have to flush the reader. Let me just take it here and just check if LOBJ reader is not equal to null, right? Because whatever happens, even if any exception happens here, let us say if any junk data is junked up into your reader pipe, then I am saying this continue. So continue again will actually continue from here, right? So just make it blank, so that even if anything happens here, anyways it will continue the whole loop, right? And then finally I'm just saying clearing it out. Yeah, fine, that's cool then. right? We're just taking care of flushing up every time, because whatever happens, I just want to clear the reader so that whatever is a new thing being written should be actually pushed to a pipe. Yeah, cool. Now let me just run this main class and see what happens. So yeah, one more thing is, let us take some sleep here, otherwise it will just, will rush pushing the data. Let us say thread dot sleep of some 1000 milliseconds, and same 1000 milliseconds will take up to the reader here. And so here, so every time it reads, let's say sys out of, I'm in thread 2, right? So before this, let's print some line gap here, right? I'm in thread 2 and this, and so when this is done, let us okay, so all these things will be actually junked up, like it will get completely into one string actually. So for that, let us remove this, because we know that I'm not printing anything in my thread 1, because I want to show you the complete clean pattern. And yeah, everything is fine now. Yeah, cool. Let's come out here to the main and let's run this one. Yeah, you can see that it is, we are filling it up in thread 1, which is creating some pattern here directly. So, and it is actually printing it out, each and every character. It is reading each and every character, and what it does is, it is actually printing up that, right? Yeah, you can see that it is printing continuously whatever is actually being read, right? So let me just give some small weight here. We have to stop it out. 8000, but 800 here, and let's go back and give some maybe some 200 here, so that writing will be faster. Let's clear it out and just run. You can see some created. So the data pushed is, anyways, it's a character by character, and obviously it will just print. So yeah, so continuously it is reading the pipe systems, and yeah, it will create your continuous patterns, right? Continuous patterns of the thing. So for that, let me just say something in here, plus some space, and let's just take something which is some 100 right here, and pattern is some 200, so I want to print it with parcel level, right? You can see it is now even printing now. Clear this up and just say go to this references, and okay, let's refill this 80 characters, let's say, okay, so that we can show it in the next line. And this, you can see the pattern is created, right? So now we are completely reading these through something called your pipe systems, right? We're just reading everything from pipe systems, where okay, so why it is not showing is it has created some 80 lines. So let me just remove this fix, right? And you can see that, right? It is actually taking up everything in one line. It is growing along, right? So that's how we it is actually reading character by character, because we're just filling up data continuously in our one pipe, right? And we're just making it read in a continuous manner, right? So that is how it goes. And if you want to actually make this kill write, so this is how it's a continuous communication between these two, right? Now you can think that if there is a trading system being deployed, right, you can create one continuous thread with a buy sells, buy orders, and you can create in the same way you can create a sell order thread, and you can make a communication. But here the only thing is, sometimes if your stream is corrupted again, right, which is a stream in the sense, whenever it's a stream, think about the pipe reader or pipe writer, so both. So when your pipe, so what is a corruption is in the sense, let us say if any junk data got accumulated at, if one byte of data is getting accumulated with the last request, right, then the whole request will be corrupted. In the same way, if whole request is corrupted, which means again it will lose some of bytes again to back the request, so each and every request will get disturbed. So for that anyways we are using something called flush, so that every time we do we do that, it will be flushed up, right? But in the same manner, what we can also do is so as we have seen yesterday, right, on Friday, so we can also do all these things using manual, where we have actually connected this object directly to this object, right, and whatever is been happening in here, so we were actually checking out that, right? You can do that in that way, right? So so that is what it is like, how it works in here, and every pattern you have to actually take care of that. So it is an infinite loop, and it will be printing continuously your data, right? And now basically whatever characters you are pushing, you can handle that character now, right, because you are getting each and every character. So if you want to actually stop at something, right, you can actually stop, where if you are stopping something in here, so you can check for some time, and you can actually kill up that. It all depends on how, so what is your requirement and how you want to actually build up the communication between these two threads, right? Yeah, so any doubts in here, guys? So this is how we use pipe system, which is under iOS. You can use, in this way you use something called pipe thing to actually make your data communication in between different threads, right? You can also use pipe out stream or input stream, where you are using something called streams there. You can also use reader writer. So these are nothing but some patterns or decorative patterns which I was talking about. You can also have something called piped output stream and input stream, right, which in turn use, so these are something which in turn uses something called byte patterns, and these are something which uses a character stream. So these two comes under character stream, and these two comes under byte streams, right? Anyways, even even if you are using character streams, right, internally they are using your byte streams. So pipe reader is using pipe input stream, and writer is using output stream. So these decorative patterns you will understand when we come to file setting, right? So this is how we can make communication between two threads using a pipes, which is under IO. Fine. Yeah. So maybe as of now, as we haven't gone through streams, right, it may look something new, or I hope it is understood. But let us, when we come to files, try to understand much better what are the streams and how we use our streams using files, right? And when we come to serialization, maybe it will be clear. So what are we what we are converting actually into bytes, and how we are saving it in our local file, and how we are reading that again to show it again, right? We'll check that when we come to file system. Fine. So that is all about the inter-thread communication of two threads. Now let's move on with use case now. So now here we'll see something which is what are the different problems that can occur from multiple threads. So we'll see that, and what is the remedy for that. We'll see one of the biggest trouble which we'll be getting here, right? Yeah. So let me take a use case here, which is we can take a use case of, again, yeah, let me take a use case of railway tickets, right? Railway tickets. Yeah. So here, so let us say I have let me take a presentation here, so that it will be much better to convey. So let us say for railway tickets, right, in two different remote areas, we have two different counters as such, right? So two different counters, in a sense, the counters which actually provide some tickets to people, right? Let me take color of here, right? Yeah. So let us say there is one counter C1, right, at some place, and there is one more counter C2 at some other area itself. Now in each and every counter, people will be standing in a queue, right? Standing in a queue. Now let us say both these guys are actually waiting to get a ticket from these counters. Now let's think that, so these two guys want to go to some place called XYZ place, same place, they want to go to the same place. Now what they'll do, they'll first do something called, they'll inquire, so how many tickets are there for place called XYZ. Now what happens, so in real time, obviously counter 1 and counter 2 guys, they won't store the data in their machines to show the inquiry thing, right? Because if it is not possible at all to make a sync between, if this guy is saving data at this place and this guy is saving data at some other place, right? Now for this, how the architects will do is, they'll create a separate database, right, which is common to all the counters, not only these two, all the counters. And what they'll do, they'll write a common piece of code, right, common piece of code, which will get you the outstanding tickets, how many tickets are there to XYZ currently. So what happens is, this method will actually talk to database and will get the data and will give you back the total number of outstanding tickets, which means C1 will actually hit this method. In the same way, your C2 will hit the same method and will get the number of tickets. Now here what we are doing is, we are just reading some data from database, that's it. We are not doing anything, we are just reading some data, and the same data is being passed to your C1 and C2. Now let's move a step ahead. Now let us say this guy over here, let me take it as guy, person A and person B. Now let us say person A and B want to book ticket to the same destination called XYZ, right? So now here you can see that these two destinations are two different counters itself, which is in some place and this can be in some other place, right? But what they want is, these two guys at a time, they wanted to book ticket, and see counter 1 person and counter 2 person hit the ticket booking for the same destination at once. So what happens, there will be one more method in the same common logic. When I say common logic, in the sense, for multiple threads, this class will be same, this method will be same for all. So let us say you have got one more method, so this method is to book ticket, so for booking a ticket, right? So this method is for book ticket. So what happens here is, so when let us say C1 and C2 are booking tickets at the same time. Now let us say, if you take in a milliseconds or microseconds level, C1's was the first request and C2's is the second request, but both came up and bombarded this method at the same time. So what happens here is, when two exclusive threads are trying to fetch a same method, so if this is a first request, which means this C1 request will go to this method and will be starting execution. Now immediately when C2 request will come up, right, what happens is, it will kill the first request and this request will be continuing. So the same pattern you will see in websites. Let us say you are in a Facebook page. If you click on home and parallelly immediately if you click on profile page, right, what happens? Which one will come up? You will see that your profile page will come up. Why? The latest request will override the old request. It happens in all the websites, right? If you click on two links parallelly, right, what happens is, your first request will be processing immediately. What happens? Your immediate fresh request will override that, and that request will be displayed to your page. In the same way, here what happens is, once two different threads are accessing the same method, the first one will be killed and second one will be moving on. Now what happens, let us say A is trying to, let us say there are total 10 tickets for XYZ destination place. Now A want to book, let us say he want to book some 3 tickets, and B want to book 2 tickets. Now theoretically, if you see this, right, so which means A and B collectively want to book 5 tickets. Now basically, once these two guys are done with booking tickets, so how many tickets will be remaining? There should be 5 tickets remaining. Now see with this request what happens when C1 and C2 goes, right, which means this is killed up, which means there is nothing been actually booked for these 3 tickets, but C1 thinks that the 3 tickets are done, but actually how many tickets are booked? 2 tickets, which means there will be 8 tickets remaining, but honestly speaking the 5 tickets should be actually remaining. In the same way, let us say C2 request was the first and C1 is the second request, and this again the second request will kill the first request, and this request will be processed, and only 3 tickets will be booked, and these 2 tickets will be overrated, which means now in this case out of 10 tickets 3 tickets will be booked, which is 7 tickets will be remaining. You can see there is so much of mismatch between whatever we need and whatever is being done. Now think about, we just discussed about two persons here. Think about how many persons will be there in a booking counter, and each and every guy will be booking multiple tickets for multiple destinations. Again, we are just talking about one destination. Then we can think about how much mismatch will, how much disaster will happen if it goes in the same way. The summary is, if you have a different threads, and if you are providing a common logic where each and every thread class is accessing, now you have to do something to this method so that how many soever, even you have a counter 3, even this guy is hitting the same method, you should actually write a logic. If you should actually provide a protection to this method so that everything will be processed, right? I hope you understood the situation here. Now to get rid of this situation, you have something called synchronization. So what is synchronization? Synchronization of threads. Now if you actually make your method, so synchronization is actually a locking an object. It is the basic use of the keyword synchronized is you are placing a lock to some object. So you can actually place a lock to a method or a block of code or something. So let us say I'm just making a lock on some method here, right? I'm placing some lock in this method, right? And what happened whenever you lock something, so how does it work is, so let us say this is a method, right? So let us just expand this class. Now let us say the common class, whatever we are talking about, let us say the class name is common, inside which we have so many variables, and I have a method for booking a ticket. Now I'll use something called synchronize here. Anyways, we'll see the example of synchronize tomorrow. Synchronize method. Now what happens is, whenever you build the class like this, right, a stack will be created. So in this stack, let us say you have got a method name method booking. Let us say it's a booking ticket method. So for separate stack memory will be created for booking ticket. Now what happens, as you're using something called synchronize keyword, right, for this memory a separate parallel memory will be created, which is called as a lock memory. For this method, it is called as a lock memory, which contains either 0 or 1. So this memory is of bit type memory, also called as a lock memory, 0 or 1. Now how it happens is, when any request comes, now let us say your C2 was the first request, and C1 is a second request, and C3 is a third request. What happens whenever C2 request comes first, right? What happens when it tries to access this method? What happens is, when C1, let us say again you have something called C1, C2, C3 requests. Let us say C1 is a first request, and C2 is the second request. So this is the first request. What happens? It will check when it tries to access booking tickets method. So parallelly, first what it does is your JVM will check this method lock memory, and it can have 0 or 1. So 0 is nothing but a free and 1 is nothing but a locked, unlocked and locked. Now let us say initially there is a 0. Now what happens? Okay, when if it is 0, which means a C1 can actually enter into this method. Now immediately when the request enters into this method, immediately your lock memory will be locked, so it will be 1 now. Now C1 is processing, is moving ahead, and what happens whenever immediately when C2 comes up, when C2 comes up and it tries to access this booking method, right, but actually this method is locked, it is 1 now. Until it gets freed or until it gets unlocked, this will be in a queue. Now until C1 completes, C2 will be in a queue. In the same way, when C3 comes up, this is the third request, again it will be in a queue. Now what happens once C1 gets completed? So once one execution is completed, right, immediately once it goes out of this method, your memory will become 0. Again when it becomes 0, again the next queue item C2 will come up, will access this method, again it goes to 1. When it completes again this method will again go to 0 state, which is empty. Again your C3 will enter and again it will lock, so C3 will be completed. Now your method is completely unlocked and it will be 0. Now you can see that when C2 tries to book, now 2 tickets are booked. Now 2 tickets are booked, and after 2 tickets are booked, C1 request will come to again 3 tickets are booked. Now you can see 3 plus 2, totally 5 tickets are booked without any issue, and out of 10 now you have something called 5 tickets remaining, right? So this is how your synchronization work, and this is a use case where you will get multiple threads want to actually access a single piece of code line, right? Then obviously there will be something called data loss will be happening due to parallel requests, right? So for that you have to use something called synchronize. Again, synchronized word is a very powerful word again, because it actually creates a separate memory lock, a bit memory lock for the whole object sometimes. Now if any exception, if any loop or if anything happens in between something in this method, and if the request is locking up, which means if it never comes out, which means this method will be locked forever. So that's why you have to make sure to which method you have to use synchronized word, right? Actually this synchronized words will actually struck up your program if anything happens in between. So you have to write this program in an optimized way by using exception handling and all, so that even if anything happens, you should come out of this method. Coming out of this method is you are actually freeing that method, so that other requests will go and process something, right? So this part of story is nothing but a trouble which we are actually coming out of using something called synchronization. Fine guys, so that is what is that is how the synchronization works here. And to for this synchronization you have something called synchronized keyword, right? Synchronized keyword, and I hope we'll see the synchronization. We need more than it's already 10 minutes now to complete the class, so we'll see this synchronization part tomorrow. So how it happens, I'll try to simulate some program, so where we can actually see how it kills a previous request, and we'll see how we can override that killing process using a synchronized, right? So fine guys, let's wind up here. So you have any doubts till now? So any doubt in this thread communication and all, right? Okay, fine. So if it is not there, so let me just take up an example, or let me just take some example how to write a synchronized method, right? So actually we can do synchronization for two things. We can actually do synchronize for either a method or a block of code. So we'll see both the things tomorrow, right? So we'll see how we can lock a method and how we can lock a block of code. So basically we use a word called synchronized, right? It is using. So nice. So this is a keyword being used to lock a method or a block of code, right? So we'll see how it gets logged and all, right? And we'll meet up tomorrow at the same time. Fine, guys. I'll see you.
Sure.
Yeah.
Sure, this is Purush. Do you have Friday recording?
I'm sorry.
Have you uploaded the Friday recording?
Yeah, I've uploaded this. Yeah, I've uploaded everything. Yeah, I just forgot something. Ron, you there?
Yeah.
Yeah, it seems you have deleted the files. Actually, I can see a request that it seems you have not copied from Dropbox. You have done some cut and paste, right? So actually when you cut and paste from the folder which I have shared, it will be deleted from my folder actually. So can you just place all the files again, or at least the last 3 classes files, so that it will be reverted back to the same folder, right? You can just copy the you can.
Yeah, I can do that. The problem is that
Yeah.
on my end it said that there was no more memory.
I'm
So,
sorry. Sorry.
On my end it said that the folder was almost full. That's why I did that. Okay, I can do that. I
No,
can
okay. You can do one thing. You just copy the last 3 classes, right? Friday, Thursday, and
Okay.
Wednesday. That is more than enough. Because see, guys, every time you see this folder, right? Do one thing. Okay. Anyways, let me do one thing. I'll keep only last 3 class files in Dropbox. I hope as your folder is only 2 GB maybe in your Dropbox, right? It may hit your in Dropbox, not in Google Drive, right? So that you can just move that, right? You can copy last 3 files, Ron.
Okay.
Every day you get a file, right? Just copy to your personal folder, so that I can clear some files and I can copy the new ones, right?
Okay.
Okay then.
I'll upload them now.
Yeah,
Okay. Thank
sure.
you.
Okay then. Okay, I'll
Yeah, Sridhar, Ujjwala here.
yeah, Ujjwal. Yeah, please. Sir.
Yeah, same thing is I didn't get any files for last week. I think
Yeah.
I sent you.
It is a
emails.
same
Then,
problem.
what I could do is, if you want, I can just copy I have all of the audio files, so I can just copy them back in.
Yeah.
And then maybe Srinath, if you want, you can just delete all of them but the last 3.
Yeah, do one thing. You can just copy back all the files, right? So that guys, whoever have got this shared, right, you can just copy all the files in your local, because we'll be deleting all the files by day end. Okay, just copy all the things from Dropbox, right? And you can actually copy it in your personal files. Okay.
Okay.
Okay then. So Ujjwal, you'll get it once Ron copies everything. Okay.
Okay, and